Hello students, how are you? I hope you all are fine. Students, my name is Sri Kasale PB, Junior College Teacher, Department of Mathematics from XII.SCI RBNB College, Sri Rampur. Students, this is my fourth lecture. In the last lecture, we have seen examples on derivative of composite functions. In this lecture also, we are going to study some slightly different examples on derivative of composite functions. Now we see examples. Differentiate the following functions. Differentiate the following functions with respect to x. Number first example is under root cos x plus under root of cos of root x. Cos of root x. And number second example is e raised to x plus 1, e raised to under root x plus 1 upon e raised to under root x minus 1. E raised to under root x minus 1. Now we see answers one by one. Now answer for first example. Consider y is equal to under root cos x plus under root cos of root x. Now differentiate this equation with respect to x. Differentiate with respect to x. Therefore, derivative of y is dy by dx equal to d by dx of in bracket under root cos x plus under root cos of root x. Now to the RHS we use addition rule, that is we can take separate derivative of these two terms equal to d by dx of under root cos x plus d by dx of under root cos of root x. Okay. Now further dy by dx equal to we have to find derivative of root of cos x. This is composite function. Suppose this cos x as a f of x, then we know that derivative of root of f of x is 1 upon 2 into under root f of x into f dash of x. Now we write here instead of f of x cos x. Therefore derivative of this term is 1 upon 2 into under root cos x into d by dx of cos x. D by dx of cos x plus similarly this is also a composite function. Suppose this underlying term cos of root x as f of x, then derivative of root of f of x is 1 upon 2 into root of f of x into f dash of x. Therefore using this formula we can write derivative of this function is 1 upon 2 into under root cos of root x into d by dx of cos of root x. Cos of root x. That is dy by dx is equal to 1 upon 2 into under root cos x as it is into derivative of this function cos x. This is a simple function. Derivative of cos x is minus sin x plus 1 upon 2 into under root cos of root x as it is into derivative of this term. Cos of root x is again a composite function. Suppose root x as a f of x, then we get cos of f of x, and we know that derivative of cos of f of x is minus sine of f of x into f dash of x. Therefore, derivative of this term is minus sine of root x into d by dx of under root x. Okay, further dy by dx is equal to minus sin x upon 2 into under root cos x as it is. Now here plus into this minus sin of under root x divided by 2 into under root cos of root x into derivative of this root x. This is a simple function. Derivative of under root x is 1 upon 2 into under root x. Okay, that is finally we get dy by dx is equal to minus sin x upon 2 into under root cos x minus sin of root x upon 2 into 2 4 into root x into cos of under root x. Cos of under root x. Now this is the derivative of given function. Answer for first example. Now similarly we can find the derivative of second function by using composite rule. Now answer for second. Consider given function as y, that is y is equal to e raised to under root x plus 1 upon e raised to under root x minus 1. Now here this is the function of the form in division form. Therefore we have to use division rule. We know that if y equal to u upon v, division rule is if y is equal to u upon v, then dy by dx is equal to v into du by dx minus u into dv by dx upon v square, where v is not equal to 0 or v square is not equal to 0. Now first we use this division rule for the derivative of this. Differentiate this equation with respect to x. Therefore derivative of y is dy by dx is equal to d by dx of, now we use here division rule. Value of u is e raised to root x plus 1 and value of v is e raised to root x minus 1. Therefore e raised to root x minus 1 into d by dx of e raised to under root x plus 1 minus e raised to under root x plus 1 as it is into d by dx of e raised to under root x minus 1, e raised to under root x minus 1 divided by v square, that is e raised to under root x minus 1 bracket square. Okay. Now further dy by dx as it is equal to e raised to under root x minus 1 as it is into derivative of this. We can use addition rule here. Derivative of e raised to root x plus derivative of 1. Derivative of e raised to root x is e raised to root x into d by dx of root x plus derivative of 1 is 0 minus in bracket e raised to under root x plus 1 as it is, derivative of this term e raised to root x. E raised to root x is a composite function again. Suppose root x as a f of x, then derivative of e raised to f of x is e raised to f of x into f dash of x. Using this formula, derivative of e raised to root x is e raised to root x upon or into d by dx of e raised to root x minus derivative of 1 is 0, divided by this term as it is, e raised to root x minus 1 bracket square. Okay, that is dy by dx is equal to e raised to root x minus 1 into e raised to under root x into derivative of this root x is 1 upon 2 into root x minus e raised to root x plus 1 into e raised to root x into derivative of e raised to root x is 1 upon 2 into derivative of root x is 1 upon 2 into root x minus 0, divided by e raised to root x minus 1 bracket square. Now further, from these two terms we can take e raised to root x upon 2 into root x common. Therefore dy by dx is equal to e raised to root x upon 2 into root x into in bracket e raised to root x minus 1 minus here remains e raised to root x plus 1 divided by this term as it is, that is e raised to root x minus 1 bracket square. Okay. Now further, dy by dx equal to e raised to root x upon 2 into under root x as it is into in bracket e raised to root x minus 1, here take multiplication, multiply by minus sign to the bracket, then we get minus e raised to under root x minus into plus minus 1 upon e raised to root x minus 1 bracket square. Now here e raised to root x minus e raised to root x cancel out. Minus 1 into minus 1, sorry, minus 1 plus minus 1 minus 2, that is dy by dx is equal to minus 2 into e raised to root x upon 2 into root x into in bracket e raised to under root x minus 1 bracket square. Now these two cancel out. So finally we get dy by dx is equal to minus e raised to under root x upon under root x into in bracket e raised to root x minus 1 bracket square. So this is the derivative of the function e raised to root x plus 1 upon e raised to root x minus 1. Okay. Now we see some different type of examples. Now next example is differentiate y is equal to log of in bracket under root 1 minus cos 3x upon under root 1 plus cos 3x. Now answer for this. Consider y is equal to log of in bracket under root 1 minus cos 3x upon under root 1 plus cos 3x. Now we know that formula, since 1 minus cos theta, 1 minus cos theta is equal to 2 sin square theta by 2, and 1 plus cos theta is equal to 2 cos square theta by 2. Using these formulas, we can write the answer for this. Here theta is equal to 3x. Theta is equal to 3x. Therefore, we can write y is equal to log of, in bracket, under root 1 minus cos 3x is equal to 2 sin square 3x upon 2. 2 sin square 3x upon 2 divided by 1 plus cos 3x means, by using this formula, we get 2 into cos square of 3x upon 2. 2 into cos square of 3x upon 2. Okay, that is y is equal to log of, in bracket, now this under root 2 cancel out, remains only under root sin square of 3x upon 2 divided by under root cos square 3x upon 2. Okay, now square root and square cancel out, remains only y is equal to log of, in bracket, sin of 3x by 2 upon cos of 3x by 2. Now we know that sin upon cos means tan. That is, we get y is equal to log of, in bracket, tan of 3x upon 2. Now we can differentiate this equation. Differentiate with respect to x again. Differentiate with respect to x. Therefore, derivative of y is dy by dx equal to, now this is again composite function, log of tan of 3x by 2. Suppose tan of 3x by 2 as a f of x, then we get log of f of x, and we know that derivative of log of f of x is 1 upon f of x into f dash of x. Using this formula, we can write derivative of this is 1 upon tan of 3x upon 2 into d by dx of tan of 3x upon 2. Okay, now dy by dx is equal to 1 upon tan of 3x upon 2 as it is, into derivative of this term, tan of 3x upon 2. This is again a composite function. Now suppose 3x upon 2 as x or f of x, then derivative of tan of f of x is sec square of f of x into f dash of x. Using this formula, we can write derivative of this sec square of 3x upon 2 into d by dx of 3x upon 2. Okay, now dy by dx is equal to 1 upon tan of 3x by 2 into sec square of 3x upon 2 means 1 upon cos square of 3x upon 2 into derivative of this term. This is a simple function. 3 by 2 is a constant term and derivative of x is 1. Therefore, derivative of 3x upon 2 is 3 by 2. Now dy by dx is equal to 1 upon tan of 3x upon 2 means sin of 3x upon 2 upon cos of 3x upon 2. That is sin 3x by 2 divided by cos of 3x by 2 into 1 upon cos square of 3x upon 2 into 3 by 2 as it is. Here cos square of 3x upon 2, cos of 3x by 2, here cos of 3x by 2 cancel out. Now remains only dy by dx equal to dy upon dx is equal to 3 upon 2 into sine of 3x by 2 into cos of 3x by 2. Now we know that formula, since 2 sin theta cos theta is equal to sin 2 theta. Now using this formula we can write value of this 2 into sine of 3x by 2 into cos of 3x by 2 is equal to sine of 2 into 3x by 2. That is dy by dx equal to 3 upon sine of 2 into value of theta is 3x by 2. That is 3x upon 2. Now here 2 cancel. Remains only dy by dx is equal to 3 upon sine of 3x. And we know that 1 upon sine means cosec. 1 upon sine 3x means cosec 3x. That is dy by dx is equal to 3 into cosec of 3x. This is the answer for example. Derivative of log of under root 1 minus cos 3x upon 1 plus cos 3x. Now we see next example again. Now next example is again differentiate y is equal to log of in bracket 4 raised to 2x into in bracket x square plus 5 divided by under root 2x cube minus 4. Under root 2x cube minus 4 bracket raised to 3 by 2. Square bracket complete. Now we see answer for this example. Consider y is equal to log of in square bracket 4 raised to 2x into in open bracket x square plus 5 upon under root 2x cube minus 4 open bracket complete raised to 3 by 2 square bracket complete. Now here we use rules of logarithm. First rule, we know that log of a into b is equal to log a plus log b. Using this rule we can write here y is equal to, this is a and this is b, log a into b equal to, we can write log a plus log b, that is log of 4 raised to 2x plus log of in bracket x square plus 5 upon under root 2x cube minus 4 bracket raised to 3 by 2. Now we use third rule of logarithm here in both terms. Since log of a raised to b or log m raised to n is equal to b into log a, b into log a. Using this rule for first term and second term we can write y is equal to 2x into log 4, 2x into log 4 plus 3 by 2 into log of in bracket x square plus 5 divided by under root 2x cube minus 4. Okay. Now first term keep as it is. Now for the second term, again we use second rule of logarithm, since log of a upon b is equal to log a minus log b. So using this rule, we can write y is equal to 2x into log 4 as it is plus 3 by 2 into, use here rule, we can write log of, in bracket, x square plus 5 minus log of under root 2x cube minus 4. Okay. Now we can differentiate this equation. Differentiate with respect to x. Differentiate with respect to x. Therefore, derivative of y is dy upon dx equal to, now here 2 and log 4 are constant terms, derivative of x is 1. Therefore, we can write here 2 into log 4 plus 3 by 2 into, in bracket, log of x square plus 5. Now this is a composite function. Suppose this x square plus 5 as a f of x, then we term becomes log of f of x. We know that derivative of log of f of x is 1 upon f of x into f dash of x. Using this formula, derivative of log of x square plus 5 is 1 upon x square plus 5 into dy dx of x square plus 5 minus, here also, suppose under root 2x cube minus 4 as a f of x, then derivative of log of f of x is 1 upon f of x into f dash of x, that is 1 upon under root 2x cube minus 4 into dy dx of under root 2x cube minus 4. Now further, dy by dx is equal to first term as it is 2 into log 4 plus 3 by 2 into, in bracket, 1 upon x square plus 5 into derivative of this. Derivative of x square is 2x. By using formula, derivative of x raised to n equal to n into x raised to n minus 1. And derivative of 5, which is a constant term, derivative of constant term is 0. Therefore, derivative of x square plus 5 is 2x plus 0 minus 1 upon under root 2x cube minus 4 into derivative of this term. Now this is again a composite function. Suppose under root 2x cube minus 4 as a f of x, 2x cube minus 4 as a f of x, then we get root of f of x, and derivative of under root f of x is 1 upon 2 into under root f of x into f dash of x. Therefore, derivative of this is 1 upon 2 into under root 2 into x cube minus 4 into dy dx of 2x cube minus 4. Now further, dy by dx equal to first term as it is 2 into log 4 plus 3 by 2 into, in bracket, 2x upon x square plus 5 as it is minus 1 upon under root 2x cube minus 4 into under root 2x cube minus 4. Into 2 into derivative of 2x cube minus 4 is, derivative of 2x cube is 6x square minus derivative of 4 is 0. That is, we can write here 6x square minus 0. Now finally we get dy by dx is equal to, we can write here 2 log 4 means log 4 raised to 2 by using third rule of logarithm. Log a raised to b equal to b into log a plus 3 by 2 into in bracket 2x upon x square plus 5 minus 6x square upon 2 into, here under root 2x cube minus 4 into under root 2x cube minus 4 means 2x cube minus 4 only. So this is the answer for given example. Okay. Now we see next example. Now next example is, assume that f dash of 3 equal to minus 1, comma g dash of 2 equal to 5, g of 2 equal to 3, comma y is equal to f of g of x, y is equal to f of g of x. Then find dy by dx at x equal to 2. Now answer for this. Consider given equation y is equal to f of g of x. Now differentiate this equation with respect to x. Differentiate with respect to x. Therefore, derivative of y is dy upon dx equal to derivative of f of g of x. By using chain rule, we can write here derivative of f of g of x is f dash of g of x into dy dx of g of x into dy dx of g of x. That is, dy by dx is equal to f dash of g of x into g dash of x. Okay. Now we have to give one value of g dash of 2, f dash of 3 and g of 2. Now here we put x is equal to 2, dy by dx at x equal to 2. dy by dx at x equal to 2 is equal to f dash of g of 2. f dash of g of 2 into g dash of 2. Therefore, dy by dx at x equal to 2 is equal to, we have to give one g of 2 is equal to 3 here. Therefore, f dash of g of 2 is 3 into g dash of 2. g dash of 2 is equal to 5. g dash of 2 is equal to 5. Since, write down in bracket reason, since g of 2 is equal to 3 and g dash of 2 is equal to 5. Okay. Now also we have to given that value of f dash of 3. Value of f dash of 3 is minus 1. Write down here, since f dash of minus 3 is equal to minus 1. Therefore, dy by dx at x equal to 2 is equal to minus 1 into 5. That is, we get minus 5. That is derivative of given function y, f of g of x at x is equal to 2 is dy by dx at x equal to 2 equal to minus 5. Now we can take similar type of examples again. Now this is a different type of example. and this example is very important for examination point of view. Now we can see more examples in exercise. We will stop here. Okay.